Now we are going to discuss how to do a mix design using the British DoE, Department of Environment method. So after collecting all information needed for the mix design, the British method consists of the following 5 steps. Calculate the water to cement ratio for the targeted strength. Decide water content for the required workability. Calculate cement content. Calculate total aggregate content and calculate fine and coarse aggregate proportions. Now let's see these steps in detail. The first step is to calculate the water to cement ratio for target strength. First, what we need to do is we find the approximate compressive strength for a water to cement ratio of 0.5 from this table 11.11. For example, if we are using uncrushed coarse aggregates with ordinary Portland cement, our approximate compressive strength is 42 megapascals. Now we are going to use this 42 megapascals and we are going to find the water to cement ratio for the targeted strength. For example, let's take our targeted strength is 40 megapascals. So the approximate strength that we found from the previous table was 42. So it is around here. And the water to cement ratio used in that table was 0.5. Now we are going to find that point on this chart. So it is somewhere here. Now we are drawing a parallel curve to these curves. So we draw a parallel curve to these curves. Now we use our target strength, which is 40 megapascals, this one, and we draw a horizontal line till it meets with the drawn curve. Now I draw a vertical line downward, and where it meets the x-axis, water to cement ratio, that will be our water to cement ratio. For example, here it is around 0.52. Now we need to check this value with any maximum limits given. So we need to select the lower value from this maximum or the found value. Step 2 is to decide water content for the required workability. So we select the water content based on the slump, maximum aggregate size and the type of aggregates. For example, let's take the maximum aggregate size as 10 millimeters and we use uncrushed coarse aggregates. And if we need a slump between 30 and 60, we need a water content of 205 kilograms in a cubic meter of a concrete mix. If we have fly ash in our concrete mix, we need to minus the free water content from this table 11.13. So if we have a 10% of fly ash, as we have taken a slump of 30 to 60, we need to reduce 5 kilograms from the previous value to find the free water content. That means we found 205 from the previous table and we minusing 5 kilograms. So the free water content after deducting the water due to the fly ash is 200 kilograms. Now we can find the cement content using this equation. We already know the weight of water, which was 200 in our example, and water to cement ratio, which was 0.52. And if we put this in our calculator, we can find the cement content in kilograms for a 1 cubic meter of concrete mix. There can be specification required to minimum cement content. We need to check that as well. This table shows the requirements to ensure durability under specified exposure conditions of reinforced and pre-stressed concrete made with normal weight aggregates. We can find the maximum water to cement ratio and the minimum cement content here. For our example, the targeted strength was 40 megapascals, so we know the maximum water to cement ratio should be 0.55. In our case, we got 0.52 as our water to cement ratio, so we are okay. We are less than the maximum mentioned in the table. And the minimum cement content is 325 kilograms. In our case, we found the cement content as 200 divided by the 0.52, which is 384.6. So our value is higher than the value mentioned in the table. So we are satisfying the minimum cement content condition as well. Also, you have some other things here as well. Depending on the condition of exposure, whether it is mild, moderate, severe, very severe or extreme, you can find the nominal cover of concrete in millimeters. So we need to consider this also when we do a concrete. We can find the same information in table 9.21 for plain concrete. Depending on our minimum grade of the concrete, we can find the minimum cement content and also the maximum water to cement ratio. And we check our calculated value with this maximum water to cement ratio and the minimum cement content, and we need to select the appropriate values for our design. Next step is to calculate the total aggregate content. To do this, we first need to find out the wet density of the concrete mix according to the free water content. For example, if we have a free water content of 200 and we need to know the specific gravity of the coarse aggregates, if it is not given, we use 2.6 for uncrushed and 2.7 for crushed. So we are using uncrushed, so that is this point, and we draw a horizontal line and we can find out here the wet density of the concrete mix. If we know the wet density of the concrete mix, we can minus the cement content and the water content, then we get the total aggregate content. Next step is to calculate fine and coarse aggregate proportions. For doing that, we have to use another set of graphs depending on the maximum size of aggregates. In our case, we use 10 millimeters as our maximum size. We also need to know the slump. In our example, we took it as 30 to 60 millimeters, and also we need to know the percentage of fine aggregate passing 600 micrometers sieve. For example, let's take it as 60%. We know the water to cement ratio, which is 0.52 in our example, so that is somewhere here, and we can find out from the y-axis of this graph the percentage of the fine aggregates. For example, here it is around 38%. So from the total aggregates, 38% is fine aggregates, 62% is coarse aggregates. If the maximum size of aggregate is 20 mils, we are going to use this set of graphs. And if the maximum aggregate size is 40, we are going to use this set of graphs. As I have mentioned before, now you can calculate the fine aggregate content and the coarse aggregate content. So to find the fine aggregates, you have to times the total aggregate content by the percentage of fine aggregates. In our example, we have 38%, so you can find the fine aggregates in kilograms. And to find the coarse aggregates, you times the total aggregate content by 62%, and you can find the coarse aggregates in kilograms. Also, you need to consider the adsorption capacity of these aggregates and the moisture coming with the aggregates, and you need to do the water correction as we did for the ACI method. With this, we are finishing the British method. You have an example in your tutorial. You can try it.